Yeah, all right. Good day, everyone. Welcome back to class. Today, we want to look at uh, a question under concentration. How to calculate the concentration of a particular substance or a compound when mixed with other compound. So, just concentration calculation. That's what we want to do now. And please don't skip any part of this video. I'm gonna show you what this video from the beginning to the end. Also, please like, share, and subscribe. And let's look at the question. They said 200 cm cube of distilled water is added to 100.00 is still sitting as 100. Take note of that. 100 cm cube of 3 molar and sodium hydroxide solution to produce 300 cm cube of sodium hydroxide solution. Calculate the final concentration in mole per dm cube. That's the question. So calculate the final concentration in what? In mole per dm cube. So let's look at how to calculate this final concentration now. It's a very simple thing. We're having two uh, stuffs in this place, water and sodium hydroxide. So we are looking for the concentration of this sodium hydroxide at the end of this experiment that is being mixed with that 200 cm cube of distilled water. So the general equation of concentration is that C1 V1 will equal to C2 V2. C1 is the concentration, that's the initial concentration. V1 is the initial volume. C2 is the final concentration. V2 is the final volume. So what was the initial concentration of this compound? The initial concentration was 3 ml of that compound. Then what was the initial volume, which is V1? The initial volume may be stated in the question. Will be stated in the question and will also be stated in the question. We can take the initial volume to be the final volume minus the volume of water that was added. For example, now the final volume was 300 minus the volume of water that was added was 200. This will give us 100 cm cube. And although this 100 cm cube was stated in the question, it was added to 100 cm cube. That was the first initial volume. You can get it from this place, or you can also get it from the question. Then what was the final volume? Final volume was what? 300 cm cube. So what about the final concentration? C2. Final concentration is unknown. We don't know this. So from here now, let's try and get this final concentration out. So we already know that C1 V1 is equals to C2 V2 divided by V2. So divided by V2, if we cancel this, our C2 will be equal to C1 V1 over what? V2. So what is C1? 3. What is V1? 100 over what is V2? 300. So from here now, I'm going to have something very nice. So I said C2 will be equal to 3 times 100 divided by 300. So we cancel this. 3 times 1, 3 times 1, that is 3 over 3. So this will give us 1 molar solution of this compound. So the condition reduced to 1. Instead of 3 molar solution reduced to 1 molar. So the next thing we're going to do will be to move this one out to mole per dm cube. I told you guys before that this capital letter M here is equivalent to mole per dm cube. Yeah, it's equivalent to mole per dm cube. So this one is simply as 1 mole per dm cube. You may decide to leave the answer this way or this way, or you may even decide to leave the answer in decimal. Also say it's equals to 1.00, depending on the number of decimal point place you want to get. 1.00, just write it well. 1.00 mole per dm cube. But the answer is 1. That's why you should just note the answer is 1. So this capital letter M here is simply as mole per dm cube. I explained that before in our first video. In case you have not watched that video, you can go back and watch it. Thank you.